Webb found a galaxy that, by every rule we had, should not exist the way it does. I want to explain exactly what that means, because it's not hype. It's confirmed in a peer-reviewed paper published May 7, 2026, in Nature Astronomy. The lead researcher is Ben Forrest from UC Davis, and what they found genuinely shocked people who study galaxies for a living. Let me start with what we knew before this. When the universe was young, we're talking less than 2 billion years after the Big Bang, galaxies were wild. They were forming fast. Gas was everywhere. Stars were being born at massive rates. And because of the way galaxies form, from clouds of gas and dust collapsing and spinning under gravity, virtually every large young galaxy was rotating. That spin is basically built in. It comes from the physics of how matter pulls together. You don't really get a massive young galaxy sitting still. That's not how the process works. The spin is part of the package. The way I understood it before this paper, and I think most people did, was that a galaxy goes through phases. First, it's young and spinning and making stars like crazy. Then, slowly, over billions of years, it runs out of fuel. The gas gets used up, star formation slows down, and eventually stops. The galaxy dies in a sense. Scientists call this being quenched. And once a galaxy is quenched and old and no longer active, it tends to slow down its rotation over time. It becomes what researchers call a slow rotator. Basically, a big, quiet, non-spinning dead galaxy. But, and this is the key point, that process takes time. A lot of time. It's supposed to happen closer to the present era, not in the early universe. So, when we see a slow rotator, a massive galaxy with no real spin, we expect to find it nearby, in our current cosmic era, after billions of years of evolution. That's the established picture. That's what the models said. That's what observations had shown us, consistently until now. This new galaxy breaks that entire timeline. What JWST found is a massive galaxy, already fully formed, already packed with stars, already done making new ones, sitting at a point in time less than 2 billion years after the Big Bang. Confirmed. That part alone is already unusual, because we don't expect galaxies that big that early. But then comes the part that I genuinely had to reread to believe. It has no detectable rotation. None. It's already a slow rotator, already quenched, already dead, at a point in cosmic history where it should still be young and spinning and active. To me, the simplest way to picture this, imagine finding an 80-year-old person who was already elderly when they were 8 years old. That's not a perfect comparison, obviously, but that's the level of mismatch we're talking about between what we found and what our models predicted. Now I want to explain why the rotation part matters so much, because that's the detail I think people might skip past. Rotation in a galaxy is connected to how it forms and how active it is. When gas falls into a galaxy, it brings angular momentum, basically spin energy. That keeps the galaxy rotating. As long as gas is flowing in and stars are forming, there's activity, there's movement, there's rotation. When a galaxy stops getting that gas, either because it used it all up or because something cut off the supply, like a massive black hole blasting energy outward and clearing the gas away, the galaxy starts to go quiet. The rotation can slow over very long timescales, especially if the galaxy merges with other systems and the ordered spin gets disrupted. The current theory says that process, going from active and spinning to dead and still, takes billions of years, not a single billion. Multiple. The timescales in galactic evolution are enormous. That's why finding a galaxy that has already completed this process, already reached the slow rotator stage, less than 2 billion years into the universe's life, is such a problem for the models we use. This is confirmed. The data shows no detectable rotation. Forrest and the team used JWST's spectroscopic instruments to look at the movement of stars inside the galaxy. Spectroscopy works by splitting light into its components and reading tiny shifts caused by motion. If something moves toward you, the light shifts one way. If it moves away, it shifts the other. A spinning galaxy shows both shifts at once, one side coming toward the telescope and the other moving away. This galaxy showed neither, just stillness. What I find impressive here, beyond the discovery itself, is that we could even detect this at all. This galaxy is so far away that we're seeing light that left it roughly 11 to 12 billion years ago. And JWST is precise enough to read the motion of stars inside it at that distance. That's what this telescope was built for, and it's delivering on exactly that. Now, why is the galaxy already quenched? That part is still being worked out. The current theory, and I want to be clear, this is still a theory, not confirmed, is that something shut off star formation extremely early. One strong candidate is the galaxy's central black hole. The current thinking in galaxy science is that supermassive black holes play a big role in quenching. When a black hole feeds aggressively, it releases enormous energy that can push gas out of the galaxy or heat it so it can't collapse into new stars. If this galaxy's black hole was unusually powerful, unusually early, it might have cleared the galaxy's gas supply long before any model predicted was possible. Another possibility some scientists suggest is that the galaxy simply used up its gas extremely fast, forming stars at such a rapid rate early on that it burned through everything and had nothing left. That's sometimes called starburst quenching. But again, these are explanations being explored. Nothing about the cause is confirmed yet. What's confirmed is the result: dead, still, massive, and ancient in all the wrong ways. For me, the most interesting layer of this is what it says about our models. Galaxy evolution models are built from observations and physics. We look at thousands of galaxies at different distances, which means different ages, because farther away equals further back in time. And we build timelines of how galaxies change. Those timelines have been tested and refined for decades. They're not guesses. They're based on real data. And yet this one galaxy sits completely outside what those models allow. It's not a small discrepancy. It's not a galaxy that formed slightly faster than expected. It's a galaxy that completed a process that should take billions of years in a fraction of that time. Ben Forrest, the lead researcher, said directly that this challenges the current timeline for how galaxies evolve. That's a measured, scientific way of saying, our picture of how this is supposed to work has a real problem in it now. What's also worth noting is that JWST has now found a pattern of early massive galaxies that don't fit our models. This isn't the first time JWST has spotted something in the early universe that was bigger or more evolved than expected. Over the past few years of JWST operations, there's been a growing collection of galaxies from the early universe that are more massive, more structured, more evolved than theory said was possible. Each one on its own could maybe be explained away, but the pattern is harder to dismiss. What I find important here is that this new galaxy adds to that pattern, and this time, the wrong thing isn't just the size or the mass, it's the dynamical state, the rotation. That's a new category of surprise. I'll be direct about what this does and doesn't mean. This does not mean the Big Bang model is wrong. It does not mean general cosmology is broken. Those are much bigger structures built from enormous amounts of evidence. What this does mean is that the specific submodels we use to describe galaxy formation and evolution, the timescales, the processes, the triggers for quenching, need adjustment. Something is either happening faster than we thought, or there's a mechanism we don't fully understand yet, or both. The confirmed finding forces researchers to revisit those models. For people who follow JWST news, and I think anyone interested in space should, this is one of those findings that actually changes what scientists have to explain. It's not a discovery that fills in a blank. It opens a new blank. Why does a galaxy this young look this old? Why is it already still? What happened to it so early in the universe's life? These are now real, active questions in astrophysics that didn't urgently need answering before May 2026. The paper was published in Nature Astronomy. The research team used JWST spectroscopy to get the data. UC Davis issued a press release the same day. NASA's science newsfeed for JWST also covered it. These are all public, verifiable sources, and the research went through peer review before publication. So here's where I land after going through all of this. We found a galaxy that formed less than 2 billion years after the Big Bang, a time when the universe was still young and chaotic, and it had already stopped spinning, stopped making stars, and gone completely quiet. Every model we had said that shouldn't be possible on that timescale. It's confirmed observational data from JWST. The cause is still being studied, but the finding itself is real, and it means our understanding of how galaxies age needs to be reworked. For me, the main thing is this. JWST isn't just seeing farther. It's finding things that genuinely don't fit what we expected to find. And that, more than any specific discovery, is what makes it one of the most important scientific tools we've ever built.